one of the most conspicuous and high-level physicists of the present day, has offered his viewpoint regarding this issue. Michio Kaku, renowned for his extraordinary contributions to the field of physics, has recently confirmed that the James Webb Space Telescope has discovered 6 massive galaxies that scientists previously thought could not exist. These findings have the potential to open new dimensions in our scientific understanding of the universe. The discovery is both exciting and revolutionary, challenging existing theories about the formation and evolution of galaxies. Consequently, it is worth keeping an eye on these developments. The affirmation by such a distinguished scientist as Michio Kaku underscores the significance of these findings. Kaku is a remarkable figure in the scientific field, a physicist of American and Japanese heritage. He is regarded as an expert in both classical experimental physics and quantum mechanics. Unlike some more conservative and skeptical scientists, Kaku does not belong to that group and has been receptive to the astounding results of the James Webb Space Telescope mission. His willingness to embrace new discoveries and share them with the public highlights his commitment to advancing our understanding of the universe. We are pleased that this distinguished scientist has chosen to break his silence and publicly share findings that can no longer be denied. The excitement and almost amused tone of the celebrated astrophysicist are evident in his remarks on the discovery made by the James Webb Space Telescope. He expressed that this revelation has been a highlight that has sparked his curiosity. Join us as we explore the implications of Michio Kaku's revelation about these 6 massive galaxies. 1 minute and 29 seconds. Michio Kaku is a scientist who has always been willing to consider new theories. Throughout his life, he has demonstrated openness to ideas that challenge the status quo, understanding that Einstein's equations of relativity and Newton's laws, while fundamental, are insufficient to capture the full complexity of the universe. Kaku understands that the discovery of these new galaxies has the potential to significantly enrich the scientific field. Although many of his colleagues have not been able to adopt this perspective, it is creating concern and sleepless nights among proponents of the Big Bang Theory and critics of quantum mechanics. However, this only provokes laughter from Kaku. The James Webb Space Telescope has revealed the discovery of 6 enormous galaxies dating back to the earliest epochs of the universe. Each of these galaxies contains more stars than our own Milky Way, despite having formed only a short time after the Big Bang. The team of astronomers who made the discovery has named these extraordinary galaxies universe breakers, as, if confirmed, they would revolutionize our entire understanding of the universe. The implications of these findings are profound, suggesting that the early universe was far more dynamic and complex than previously thought. Something no longer fits. The Big Bang Theory tells us that the universe was chaotic after the initial event. Solid structures were believed to have taken millions of years to form, and it required millions more years for those structures to reach sufficient density to emit light. The formation of complex structures, such as galaxies, was thought to occur much later. Some of the discovered galaxies surpass the Milky Way in size, and their immense luminosity indicates that they were likely forming many new stars each year, whereas our galaxy forms stars only sporadically. It remains unclear exactly when the first galaxies formed. Researchers have not yet been able to determine this. What is clear is that initially, there may have been only individual stars or clusters of stars, which eventually merged to form progressively larger conglomerates until dwarf galaxies developed. These small galaxies interacted with others, gradually growing in size. By past theories, highly organized and massive galaxies could not have existed at that time. This raises the question of whether the universe is much older than previously believed or whether complex cosmic structures developed much earlier than expected. This scenario is difficult for conservative science to accept, as it still finds issues with this model. Certain branches of physics strongly resist accepting this discovery and question possible errors in the age calculations. Michio Kaku is aware of this and had this to say. There are numerous examples of old and incorrect theories that stubbornly persisted due to the prestige of certain scientists. Many of these theories were only disproven when a crucial experiment revealed their flaws. Thus, the fundamental work in any science, particularly physics, rests with experimentalists who keep theorists on their toes. In fact, on Earth, we know very little about the true origins of the universe. This statement from Kaku underscores the importance of constant experimentation and validation in the scientific process. The Big Bang Theory was established in 1927 based on observations of the expansion of the universe. These data led to the conclusion that the universe began from a single point and has been expanding ever since. At the time, it was difficult for people and scientists to imagine a universe with a beginning and an end. The idea of a universe that had always existed and was infinite was beyond people's imagination. Even today, scientists still face challenges in understanding it. However, it is crucial to consider these possibilities. Once again, the new findings do not align with the assumptions that researchers have relied on for decades in relation to the Big Bang theory. However, science has demonstrated time and again that re-evaluation and openness to new ideas are an integral part of the scientific process. This includes the validation of certain theories and observations. When Einstein was a child, it was believed that the stars and planets were firmly fixed in the universe and occupied defined spaces. However, we now know that everything in the universe is moving. Planets orbit stars, stars move within their galaxies at hundreds of kilometers per second, and entire galaxies move rapidly through the universe, the fate of which we cannot yet predict. This dynamic understanding of the universe challenges long-held beliefs and highlights the need for ongoing inquiry and adaptation in scientific thought. Today, scientists are challenged to accept uncomfortable truths and understand that theories are not absolute truths until they are rigorously tested or confirmed by empirical observation. The Big Bang theory arose from the realization that galaxies are moving away from one another, and this distance is proportional to their separation from Earth. This observation, known as Hubble's law, suggested that the universe was expanding. For some time, elements such as cosmic background radiation and the redshift of light from distant galaxies appeared to support this theory. However, it is important to remember that, in the past, people who believed that the Earth was flat and that the Sun revolved around it also had physical evidence for their assumptions, until new technologies and insights provided a clearer and more accurate picture. We are now witnessing a similar situation. Researchers expected the James Webb Space Telescope to confirm assumptions related to the Big Bang. Instead, they have encountered 6 galaxies that seemed impossible. As a car moves away, the sound becomes fainter. Similarly, in the universe, light waves stretch as objects move farther apart, shifting toward the red end of the spectrum. This phenomenon allows astronomers to determine the velocity and distance of celestial objects. The redshift measurements from the James Webb Space Telescope have revealed that these 6 massive galaxies existed when the universe was only a few hundred million years old, a timeline that contradicts our current understanding of cosmic evolution. These galaxies should not have had enough time to accumulate such mass or form so many stars. This discrepancy has sparked intense debate among scientists, some of whom suggest that there may be fundamental gaps in our knowledge of the universe's early stages. 8 minutes and 5 seconds. One possibility is that these galaxies formed through entirely different mechanisms than what current models predict. Alternatively, the universe might operate under laws or principles that have yet to be discovered. Some researchers have even speculated that the early universe might have been subject to conditions vastly different from what we experience today, potentially involving exotic matter or faster-than-expected star formation rates. Despite the skepticism of some in the scientific community, Michio Kaku has embraced these findings as an opportunity to expand our understanding of the cosmos. His open-minded approach has garnered widespread attention, inspiring many to revisit long-standing theories and explore alternative explanations for the universe's origins and evolution. Kaku emphasizes the importance of remaining adaptable and willing to question established paradigms. He believes that this discovery could pave the way for groundbreaking advancements in physics and cosmology, much like how previous paradigm shifts have revolutionized our understanding of the natural world. As we delve deeper into the mysteries unveiled by the James Webb Space Telescope, one thing is certain: science is far from static. It is a dynamic and ever-evolving pursuit of knowledge, driven by curiosity, experimentation, and the willingness to embrace the unknown. These 6 universe breakers have not only challenged our current understanding of the cosmos, but also reignited a sense of wonder and excitement in the scientific community. They remind us that there is still so much to learn about the universe we call home. 9 minutes and 33 seconds. Anyway, once the vehicle passes you or moves away, the motor's sound changes. This is because the motor's sound varies as the vehicle moves. The same is true for light. When a light source, such as a distant star, moves toward us, the light we see shifts toward bluer shades. On the other hand, when the light source moves away from us, the light shifts toward redder hues. This phenomenon is called redshift. Physicists have converted redshift values into speeds and distances for measurements in the study of the universe. However, it is important to note that small errors in these measurements could have significant effects. The measurement methods previously used are currently under review, and it will be interesting to see what conclusions scientists arrive at regarding the latest findings related to our universe. It is important to consider whether these results are truly based on redshift errors or if some scientists are simply denying certain facts. This is a question that requires thorough investigation and careful review of the data and methodologies used in the research. The current analysis and reassessment of measurement techniques highlight the evolving nature of scientific inquiry. 11 minutes and 1 second. Thank you kindly for watching the video. As always, we encourage you to post your questions in the comments section. If you liked Michio Kaku's analysis video, don't forget to hit the like button, share it so it reaches more people, and subscribe to the feed so you don't miss more content like this. Thank you kindly for watching, and see you in the next one.